Well, welcome back to another lesson in our flipped classroom series. This is titled Domain and Range. So let's go ahead and get these definitions down. 1. The set of all inputs, or x values, are known as the domain. And 2. The set of all outputs, or y values, are known as the range. Maybe that sounds familiar to you, and that's awesome. You probably talked about it in Algebra 1, but we'll review it again here in Algebra 2. So what do we need to get down is that the x values are referred to as the domain, and the y values, or the outputs, are referred to as the range. So there's several ways to do this, and the first one we're going to tackle is finding domain and range graphically. So again, to find the domain, here's what we want to write down. We're going to identify the x min and the x max. And then in the range, we want to identify the y min and the y max. So let's go ahead and look at this example. Now, you probably don't have graph paper, and that's okay. If you could just make a quick sketch in your notebook, like a quick x and y axes, and then just sketch that in. Take note that there's an open hole and there's a closed hole. Okay, so our goal is to first start off by identifying the x min. So what does that mean exactly? Well, I'm going to start by going to the x-axis, okay, for x min, and I want to find the smallest value on the x-axis that this graph goes to. So if I follow the graph and I go to the x min, if I go out this way and I follow this graph, the farthest to the left that it goes, I would say, is -3 on the x. Do you notice that graph doesn't hit -4 out here anywhere? It doesn't hit -5. The smallest, so the x min, I would say, is x equals -3. Now I want to do the same thing on the x-axis, but I want to go in the maximum direction. So if I go out to the right for a max, and again, I'm only looking at numbers on the x-axis. The graph has a height at 1, has something at 2, it's got a hole there, but does it ever hit 3? No. So my x max, the farthest this graph goes to the right, would be 2. And once you identify the x min and x max, you have your domain. How far to the left did it go, and how far to the right did your graph go? Now there's two ways to identify domain. You can use something called interval notation, or you can use something called set builder notation. Now, it doesn't matter to us which one you go with, but you should be aware of both of them in case it's written as a multiple choice question. So, I'll review interval notation. Interval notation has you looking at these endpoints to determine if they're going to be open or closed brackets. So if I look at this x min, we said at -3, it's a closed circle, so that gets a bracket for a closed circle. And then I'll just put -3 in there, comma. I'll put my max number in there. And then you'll take note, if I look at this open circle, that gets a parenthesis. Okay, so maybe you need to make a side note in your notebook for yourself. A bracket is for a closed dot, and a parenthesis is for an open dot. Now, in set builder notation, it's similar, but we use inequality symbols. So I start with -3. I put an x in the middle because I'm domain, and I put a 2 on the end here. Okay, and it always goes in order from min to max, min to max. And then I just say -3 is less than, and again because it's a closed dot, I'm going to say less than or equal to x, which is less than, and it's an open dot, so I'm just going to leave it as less than 2. Okay, but I can't stress enough, the min comes first, the max comes second. Now for range, we're going to do the same thing with the y values. So this time I'm going to go to my y-axis this time, and I'm only focusing on those numbers. So I'm looking at the y-axis, and these are my only options for numbers. And I want to say, what's the y min? What's the lowest this graph goes? Well, if I get to this point, can you go any lower than this point? No, the graph stops there. So if I look to the right on the y-axis, I would say my y min is y equals -5. My y max, I'm just going to go up to the highest I can see on the graph. And the highest looks like right here, and I would say that's y equals 4. And again, once you've identified that, you're pretty much done with domain and range. You're just looking for the min and the max. So back in interval notation, I'm going to go -5, 4, and now I just need to determine if it's a parenthesis or a bracket. So if I look at the -5 on the y, I see that had the closed dot, so remember that's the closed bracket. And if I look up at 4, you'll notice that there's not a big hole. Okay, it's not open, it's closed. If you don't see a big hole, it's closed. So this gets a bracket as well. Then in set builder, I'm going to go -5. Notice I'm going to put y in the middle because I'm talking about range in 4. And then because they were both closed, they're both going to get the less than or equal to symbol. And again, I can't stress enough, mins come first, max comes second. So again, I think it would be helpful if you just made a quick axes and sketch, and we're going to do 2 more here. Now, what I want you to do is I want you to pause it and try this one right here on your own. And basically, I just want you to identify the x-min, x-max, any way you want to write the domain, y-min, y-max, and the range. And then we'll work on this one together. So pause it, give it a whirl. Okay, I tried to squeeze all my answers on here. My x-min, so I looked at my graph and I said the farthest to the left, or the smallest number this reaches on the x-axis, I'm only looking on the x, is 1. And the x-max, the farthest it reaches to the right, would be 5. So I have an x-min of 1, x-max of 5. Both closed dots take note, so I said brackets 1 to 5. Or in set builder, you could use the inequality symbol. Then for y-min, I said the lowest the graph goes is to a height of 1, and again, I'm only using the y numbers. And the highest would be 5, again, both closed, so close brackets. And if you use set builder, make sure you put the y in the middle. Now, I wanted to do the other one together. All right, so x-min, I want you to go to this x-axis, and I want you to tell me if this graph ever stops. Notice this graph has arrows on the end, so that means it keeps going and going and going and going. So can you tell me where the x-min is? Does this graph ever stop, or does it just keep slightly going out and out and out and out? Okay, since it never stops, the x-min, we're going to say, is -infinity. It goes on forever. The x-max, does this graph stop moving to the right, or does it slowly keep creeping out as this gets bigger? So I'm going to say this is +infinity. Therefore, my domain is -infinity to +infinity. And this gets parentheses because you can't actually reach infinity. Now, if you wanted to write that in set builder notation, here's the goofy symbol. You could write out the words all real numbers, so go ahead and do so. Or the quick notation is a capital R with 2 vertical lines. So let me show you. I'm going to make 2 vertical lines and draw an R. And that stands for all real numbers. So get that notation written down for yourself. Okay, as far as y-min goes, so now again I'm going to the y-axis. Does this graph have a low point? Well, yeah, it doesn't go past this point on the y-axis. So if I look over to the y, I would say that's a y equals 2. Now how about a y-max? Does this graph stop going up, or does it go up forever? Okay, again, those arrows imply that it's going up forever. So my y-max is going to be infinity. So again, 2 ways to write the range. I can say from 2 to infinity. Now you'll notice 2 has a closed bracket because it's a solid dot and you can never reach infinity, so that's a parenthesis. Or you can say the y values are always greater than or equal to 2. Okay, now you'll notice this last graph that we tackle here is a little different. It's kind of split up into 2 sections. There's a piece here, and then it breaks apart, and there's a piece here. So how would I describe this graph is I would say that it is discontinuous. Okay, so it's not one graph all connected. It has a break in it. Therefore, it's discontinuous. If you were to try to drive on it, so to speak, you would drive up this way, and then you'd have to jump off and basically drive onto this section. It's not one continuous flowing pattern. So since it's discontinuous, you need several pieces to write the domain and range, basically one for each section. So I'm going to start with just this corner here, because like I said, we need several pieces. So in that section, I need an x-min and an x-max. Okay, so again, I'm looking strictly at the x-axis. Does it ever stop going to the mins on the x-axis, or does it go forever? Well, again, that arrow implies that it's going forever. So I'm going to say that's towards -infinity. Now, the x-max. As I go this way in just this section, okay, you'll notice that the graph doesn't keep going forever this way. It goes up forever, but it doesn't hit this line here. And there's something called an asymptote there. And I'm going to slightly draw it in. There's this magic line called an asymptote. And we'll talk more about that later in the year. You definitely talked about it in Algebra 1 when you did exponential functions, but that might have been a long time ago. Now you'll notice the scale is counting by 2s, right? 2, 4, 6, 8. So this is getting close to 2, but it's not touching it. So I'm going to say my x max is 2, even though it doesn't touch it. Okay, now I'm going to do the same thing for this section here. I'm going to write a separate x min and a separate x max. Okay, so if I look at this graph, again, on the x-axis only, it looks like it gets close. My bad, that should have been a -2. It looks like it gets close to -2, but it doesn't touch it because of that asymptote. And if I look for my x max, that arrow is implying it goes forever. So I'm going to say my x min is -2 and my x max is positive infinity. So since I had two sections, when I go to write the domain, I have to break it up into two pieces, and I'll show you how. I'm going to say from -infinity to -2. Again, I can't reach infinity, so that got a parenthesis. And I didn't actually hit -2 because of the asymptote, so that gets a parenthesis. And I'm going to unite that with the interval from -2 to positive infinity. So when there's two sections, don't forget you need two pieces to your domain. Likewise, for range, when there's two sections, you're going to need two sections to your range. So let's go ahead, it's the same graph, and let's just look at the range now. Okay, so I'm going to look at both sections. So I'm going to start with this section that's to the left first. I need my y min, my y max. Okay, so now I'm looking at the y-axis. How high and how low does this graph go? Well, again, you're going to see like this asymptotic line in here that it looks like they're both getting close to. So I'm going to draw it in with my red pen. And I'm going to say it looks like they're getting close right in the middle there, but they're not touching it. So I would say the lowest this graph goes is close to a +3. Again, they're counting by 2s. And if I follow it up, it goes up forever to infinity. When I look at the other section, I need, again, a y min and a y max. If I look at this section, again on the y's, it goes down forever, so my y min is -infinity. And it doesn't go up forever, it only gets close to this asymptotic line, which was at 3. So when I write my range, I'm going to say from 3 to infinity, union, -infinity to 3. So moving on from graphing, they can just give you different ways to look at functions, and you can just identify the domain and range in a roster. So remember, the x comes first, y comes second, domain is your x, and range is your y. So if they ask for the domain of this mapping, they're really just asking you to list out the x values. So I would say my domain are my x values, so 2, 3, 4, and 5. And I would say my range are just my y values, so 8, 9, 10, and 11. Okay, so I'm just identifying the x and the y again. In question 2, same idea. I want to identify the domain. So I'm just going through and saying, okay, domain is my input or my x values. So I am just listing out the x values. So 2, 5, 8, and 9. And then my range, of course, is my y values, and I'm just going to list them out in roster form. 5, 7, 6, and 2. Now if you want to put them in numerical order, that's fine as well. Our last piece is to identify the domain and range given an equation. So let's go ahead and title that in our notebook so it's easy to find. And how do you do that? Well, the first thing I do is I ask myself if there are any restrictions. Once I come up with an answer to that, I'll write my domain and range. And then, of course, I want to make sure I verify graphically. You can't get it wrong with the graphing calculator. We'll just type it in and compare. So look at 3 quick examples. Number 1, y equals 5x plus 3. Hopefully, you're familiar with this equation. This is just the equation of a line. Okay? Has a slope of 5 and a y-intercept of 3. So I'm going to ask myself that question. Are there any restrictions? Is there any number you are not allowed to plug into x? I would say no. I can plug in a 0 if I want, a 2 if I want, 100,000 if I want, a -5 if I want. I can plug anything I want into X. So what that tells me is the domain, because I can plug in anything I want, the domain is from -infinity to infinity, if I'm using interval notation, or if I use set builder, I could say all real numbers, or you could write that out, all real numbers. Okay, now my second step, like we said, was to verify with a graph. So let's grab our calculator and get a picture of this graph. So I hit my y equals on my calculator and typed in the 5x plus 3, and this is what I got. Okay, and again, it's a line like we predicted, and if I look at my x min, okay, if I go to the x-axis, this graph just keeps going forever and ever and ever, so I would say -infinity, and this graph goes forever and ever and ever, so again, +infinity. So my domain is all real numbers. Okay, let's take a look at one where there probably is a restriction. Number 2, y equals the square root of 3 minus x. So again, I'm asking myself, is there any number that I cannot plug in? So think square roots in your head. Do you know the square root of every number in the world? Well, even though some of them aren't nice, you may know a lot of them. For example, if I plug in x equals 10, I would get y equals the square root of 30 minus 9, so the square root of 21. Now, even though I don't know what that is off the top of my head, I can still do it on my calculator. I get some random decimal. But there are numbers you can't take the square root of. Can you think of them? Can you take the square root of -4? No. If you try it on your calculator, it's going to give you an error. You cannot take the square root of negative numbers. Okay, so there is a restriction when you have radicals. So what does that tell you to do? Well, basically that means whatever's under here, and let's make a note, must be positive, because I cannot take the square root of a negative number. So if it has to be positive, basically I'm going to say whatever's under there has to be something to 0. If you're a positive number, what are you compared to 0? Well, I would say you're greater than or equal to. You can equal 0 because the square root of 0 is 0, but you can't be negative. And now all you have to do is nicely solve this equation. So I'm going to add 9 to both sides. So 3x has to be greater than or equal to 9. And then I'll divide by 3. So x has to be greater than or equal to 3. And that's my domain. X is greater than or equal to 3. Now notice that's in set builder notation. If I wanted that in interval notation, I would say 3 is the min because the x numbers are bigger. So I would go from 3 to infinity. It's equal to 3 because of that equal sign. And I can never touch infinity, so it gets the parenthesis. Okay, so anytime you see a radical, you have a restriction. I just wanted to take a quick moment to verify it graphically. Okay, you can always just type it in the calculator, and you'll see that the smallest x value right here is 3, and that's exactly what we said. And then the x values are all bigger than, because that goes on forever. So again, if it's multiple choice, I would type it in my calculator and just look at it. All right, I've got one last one for you, and it's probably the ugliest one. So again, I've got y equals x minus 6 over x plus 3. And I'm going to ask myself, are there any restrictions? Is there any number I cannot plug in? Well, when you have a fraction, there is one rule. There is one number in the world you cannot divide by. And let's get this down right now. You cannot divide by, you've probably said it by now, 0. Okay, again, if you try to divide by 0, if I type in 5 divided by 0 on my calculator, it says error, divide by 0. You're not allowed to. It doesn't happen. It's impossible. Okay, and what that does is it makes that fraction undefined when you try to divide by 0. So when you have a fraction, you don't really care what the numerator says, so to speak, at the moment. All we care about is the bottom. I cannot let this number on the bottom equal 0. Off the top of your head, could you tell me what x value makes that denominator equal to 0? Good, -3. X cannot equal -3. Now, if you couldn't come up with that, it's simple. We'll just say x plus 3 cannot equal 0. This denominator can equal 0. That's the only rule. So I'm going to subtract my 3 over, and x cannot equal -3. Okay, so my domain, I'm allowed to plug every number in the world I want except -3. How do you write that out? Well, there's two ways. You could say all real numbers except x equals -3. So that's one way to say it. Or you could say from negative infinity to negative 3, union, negative 3 to positive infinity. Now notice, even though I use negative 3 twice, I don't have a bracket around it, so it's never equal to. So 2 ways to say the same thing. And again, my last step is going to be to check graphically. So here's a quick graph from my calculator. You'll notice it's in 2 pieces. That's why it makes sense that I have these 2 intervals, one for this section and one for this section. And you can kind of see that it looks like they're getting close to the same point but not touching, so it has what we call that asymptote in there, and it happens at negative 3. So this can be all real numbers except negative 3. And lastly, let's go ahead and make a table. All I did is after I graphed it, I hit the table feature, and you'll notice, and you can circle this in your notebook there, at negative 3, what do you see? An error. That tells me all the other numbers work except negative 3. And again, that's where that asymptote is. Well, we look forward to seeing you tomorrow. Have a great night.